Hello, class. I'm Dev,
Hi, I'm Gautam.
Hey, my name is John.
and today you guys will be learning about the famous cocktail shaker sort. So, the first thing that probably came to everyone's minds is who on earth named this sorting algorithm? We have sorting algorithms called quicksort or selection sort, which have fairly simple names and can give you a small idea of what the algorithm may be for. But why is this one called a cocktail shaker? To understand the meaning behind the name, we first need to acknowledge where this sorting algorithm is originated from. The bubble sort is a simple algorithm that compares side-by-side elements of an array and swaps them if they are in the wrong order. The thing to know about the bubble sort is that it only functions in one direction. Okay, so let's look at this example. This is a 5-element int array that is not in ascending order yet. The bubble sort will begin from the leftmost element of the array, and it will compare its adjacent element until it reaches the rightmost element of the array. In this case, 5 to 1, and it swaps values as it moves from left to right. Once the sorting has reached the rightmost element, bubble sort will begin back from the beginning and continue to do this at the same procedure until the array is all sorted out. The cocktail shaker sort is a variation of the bubble sort and is also known as a bidirectional bubble sort. It's called that because the cocktail shaker sort functions in two directions rather than the one direction that the bubble sort works in. Let's see how this cocktail shaker sort handles this same array. Like the bubble sort, the cocktail shaker sort begins with the leftmost element of the array and swaps the pairs that are in the wrong order as it moves to the right. Now the new thing about the cocktail shaker sort is that it doesn't start back from the beginning of the array like the bubble sort and check all over again. But now it starts from where it ended off, which will be the rightmost side of the array, and begins to sort in the opposite direction. And once it reaches the leftmost side, it repeats the same pattern. And looking back at the variation name given to it, which is the bidirectional bubble sort, it makes a lot of sense to why it's named that. Well, now you guys have a better understanding of how the cocktail shaker sort works and where it's originated from. But you guys are still left wondering on why it's called a cocktail shaker sort in the first place. Well, since we now know that the sorting method operates in two directions, we just have to take a better look at how a cocktail shaker operates. People who are most known for using a cocktail shaker are bartenders. And bartenders use both a forward and backwards motion to shake the cocktail, and yes, therefore giving the name cocktail shaker sort. Don't worry if you guys are still a little confused on how the cocktail shaker sort works, because lucky for you guys, we have John, who will show you beginners an amazing step-by-step process on how the cocktail shaker sort works in real time using coins.
A cocktail shaker sort is another sorting algorithm, and today I'm going to show how it works. So here I have some coins, and they're going to represent values in an array. And using the cocktail shaker sort, we're going to rearrange them from least to greatest. So to start the cocktail shaker, we're going to do a bubble sort from the left to right. So the toonie is greater than the loonie, so we're going to switch them. Toonie is bigger than the nickel, so we're also going to switch them. The toonie is bigger than the quarter, so we're going to switch them. And the toonie is bigger than the dime as well, so we're going to switch them. The toonie and toonie are equal, so we're just going to leave them as they are. Now, normally for the bubble sort, we'd go from the left back to the right again. But using the cocktail shaker, we're going to do the same thing, but backwards, so from the right to the left. So we just said that these two do not need to be rearranged. Now, these two are also in the right order. These two need to be switched, so we're going to switch them. These two are in the right order because we're sorting by value, and these two need to be switched. And then we're going to go again. These two we just switched, so we know that we don't need to switch them again. The loonie and dime, we'll switch them because the loonie is bigger than the dime. These two are also need to be switched, so we're going to move them. These two do not need to be switched, and these two don't need to be either. And we're going to go backwards again. These two can stay as they are in the right order. These two are in the right order. These two are in the right order. These two are in the right order. And these two are in the right order. So using the cocktail shaker, we have arranged these values into least to greatest value.
Welcome back, everyone. hope you guys now have a better grasp on cocktail shaker sort. But the big question still remains, what is the point of using the cocktail shaker sort when you can just use the simple bubble sort method? Well, let's take a look at our previous example. Both methods gives the same final result, but at what cost? If you were trying to calculate the amount of tries it takes to bubble sort algorithm to sort this array in ascending order, it would take 4 tries from left to right, or 4 of those red arrows. However, if you use the cocktail shaker sort method, you will only need 3 of those red arrows, which makes it more efficient. Wow, one step easier? I know what you guys are all thinking, but this is just a 5-element array. As you increase the size of your problem, the cocktail shaker sort will become that much more efficient, because every time it goes back and forth, it puts the smallest and largest value at each end of the array, and then it doesn't need to compare those values, and it can now work with the smaller set of elements in the middle. The big O notation, or the efficiency of the algorithm. Cocktail shaker sort has an average performance of ON squared. If we look at this graph below, we can see that ON squared is not actually really good or efficient, but this is also the worst case possible for the cocktail shaker sort, and the performance becomes closer to ON if the list is more sorted, which is the best possible case for cocktail shaker sort. The cocktail shaker sort is not as efficient as, for example, like something like the quick sort, which has an average performance of O log n, but is fairly more efficient than the bubble sort because it can operate in 2 directions. Now that you guys understand all aspects of the cocktail shaker sort and how it differs from the bubble sort and its efficiency, we can now look at the practical side and how it's actually used in code. Gautam will now finish the lesson off by teaching us how to code the cocktail shaker sort algorithm using Java.
Hello everyone, this is how to code a simple cocktail shaker sort in Java. I will be using a while loop with 2 nested for loops to do this. I created a void class method which will do the swap. You first want to have 2 variables, one for holding a temporary value and the other for holding a boolean value of whether there was at least one swap during the sort. You would then want to have a while loop which runs while the variable swap is true. This means it will run while there was at least one swap that occurred. Once it enters the while loop, you would change the value of the swap to false. This is so the while loop doesn't break. You would then create a for loop which goes from 0 to the length of the array -1. If you do not add the -1, you will get an array index out of bound exception. In this for loop, you are going from left to right, just like a bubble sort. You will then check with an if statement whether the value at array index I is greater than the value at the index after it, which is I plus 1. If it is greater, you would swap the values of both using the temporary variable. You would also set the swap variable to true because the values were swapped. After this for loop, the largest value will always be in the last index. If the while loop performs a second time, the second largest value will be in the second last index of the array. You would then check if there were any values that were swapped in the previous for loop and break the while loop if there weren't any. After this, you would set the value of swap back to false. You would then create another loop which goes from the length of the array -2 to 0. This would mean you are going from right to left. You would then use the same if statement from the first for loop, and by the end of this for loop, you would have the greatest value in the last index and the smallest value in the first index. If there was a swap, the while loop would run again, but if not, it would leave the loop and would also end the method. The values of the array would be in increasing order by the end of the method. In the main method, I created an int array, which has the values 10, 3, 5, 3, 1, 9, and 1. I then call the cocktail shaker sort method, and now the array R has the values 1, 1, 3, 3, 5, 9, 10, which you can see in the run bar. This is the entirety of the code.
Now time for everyone's favorite part, Kahoot. So grab your phone or laptop and get ready to challenge yourself and answer some intricate questions on cocktail shaker sort. The questions should be fairly easy if you guys were paying attention, and the results on the Kahoot quiz will make your concentration evident. And remember, bonus marks for the top 3 winners.